guys, welcome back to my channel. I'm Abby, and today we're going to tackle the unit circle. We're going to discuss what the unit circle is, how we can use it to solve trig functions, and I'll share with you my story I used to memorize the unit circle so you'll never be able to forget it. Let's get to it. First, let's review sine and cosine. We can use sine and cosine to help us find side lengths of a right triangle. To do this, we just take cosine of theta times the hypotenuse, and this will give us the length in the x direction. To get the length in the y direction, we multiply the hypotenuse by sine of theta. So to find the coordinates of a point, we can use cosine to find the x coordinate and sine to find the y coordinate. Now, let's review arcsine and arccosine. We use these functions to help us find the angles opposite or adjacent to the given side length of a right triangle. So for example, if we had this triangle where this side next to theta is 1 and the hypotenuse is 2, we would need to figure out what theta is. So to find theta, we would take the arc cosine of the adjacent side divided by the hypotenuse. So using this equation, we would take the arc cosine of 1 over 2. Now if we were given the side opposite of theta instead, we would use arcsine instead of arc cosine. So to find theta, we would take the arcsine of the opposite side over the hypotenuse. If our opposite side is square root of 3, this would give us arcsine of square root of 3 over 2. It's important to remember that arcsine can only accept values that lie between -1 and 1, and arcsine only gives angles that are in between negative pi halves and positive pi halves. Arccosine also only accepts values from -1 to 1 and gives angles between 0 and pi. Now we'll finish solving these in a minute using the unit circle, but first, what is the unit circle? It's a circle with a radius of 1 and it has common angles and their corresponding sine and cosine values. Now, not only are the degree angles on the unit circle, but so are the radian angles. But hold up, what is a radian? A radian is an angle measurement that is based on the relationship between a circle's circumference and radius. Let's break this down further. So a whole circle is 360 degrees, or 2 pi. But what if we wanted to know this angle? To find the angle in terms of radians, we take the length of this arc and divide it by the radius. 1 radian is when the length of the arc is equal to the radius. Because a radian is a length divided by a length, those units will cancel and leave your answer unitless. However, you can still label your answer with radians or rad, so you know for sure that your answer is a radian measurement. Okay, so we understand the unit circle, but how do we use it? Let's look at an example. If we need to find sine of 45 degrees, we find our angle 45 degrees on our unit circle, and we look at the y-coordinate because sine is what gives us the y-coordinate. So, sine of 45 degrees is square root of 2 over 2. And we can do the same thing for radian measurements. So, for example, let's solve f of pi over 6, where f of x equals cosine of 7x. So we plug pi over 6 into f of x, and we get cosine of 7 pi over 6. So, now we're looking for the angle 7 pi over 6 on our unit circle. Remembering that cosine gives the x-coordinate, we now know that cosine of 7 pi over 6 equals negative square root of 3 over 2. To solve for arcsine and arccosine, we do the exact opposite of what we just did. So let's finish those examples that we started at the beginning of this video. We left off with arccosine of 1/2 and arcsine of square root of 3 over 2. Starting with arccosine, we want to find where 1/2 is the positive x-coordinate, and we'll find the angle we're looking for. And remember, arccosine spits out angles from 0 to pi, so we ignore the bottom half of the unit circle. So right here, we see positive 1/2 as the x-coordinate, and its angle is pi over 3, or 60 degrees. We do the same thing for arcsine. To find arcsine of square root of 3 over 2, we find where square root of 3 over 2 is the positive y-coordinate. Remember that arcsine spits out angles from negative pi halves to positive pi halves, so we can ignore the left side of the unit circle. So here, we see that arcsine of square root of 3 over 2 also equals pi over 3, or 60 degrees. If we ever need to convert from degrees to radians, or radians to degrees, we will use one of these two conversions. The one on the left converts from degrees to radians, and the one on the right converts from radians to degrees. Let's go back to the unit circle. Look at it. It's kind of a beast to look at. How will we ever remember these sine and cosine values? Well, let me share my story with you as we take a look at this first quadrant. So let's pretend we have our own little personal rocket sitting here on the x-axis, and it's ready to blast off into space in 3, 2, 1. Now that our rocket has made it to space, it's ready to come back down. So its boosters give another blast in 3, 2, 1. Well, unfortunately, even with a parachute, the rocket crash landed and split in half. So we will divide each number by 2. And the parachute slowly falls down and covers the rocket. So let's cover these top numbers with a square root. Now, the square root of 1 divided by 2 can be simplified to 1/2 if you'd like. And that was the hardest part. The rest of this circle is easy. Let's find the coordinates of 0 and 90 degrees, or 0 and pi halves. So cosine of 0 degrees is 1, and sine of 0 degrees is 0. Cosine of 90 degrees, or pi halves, is 0, and sine of 90 degrees, or pi halves, is 1. Sweet! Now we've got the first quarter of the unit circle. But guess what? That's the best part. You only need to know this quarter of the unit circle, and you have the rest of it mastered. To fill out the rest of the circle, we take the coordinates in the first quadrant and reflect them across the y-axis to the second quadrant. Now, the x-coordinates are all negative because they are moved to the negative side of the x-axis, and the y-coordinates stay positive because they're on the positive side of the y-axis. Now we can take these coordinates in the second quadrant and reflect them over the x-axis to the third quadrant. The y-coordinates are now negative because we're on the negative side of the y-axis, and the x-coordinates stay negative because they're still on the negative side of the x-axis. Taking these coordinates from the third quadrant and reflecting them back over the y-axis to the fourth quadrant gives us positive x-coordinates, and the y-coordinates remain negative. Now, to remember these radiant angles, we just need to remember 2 types of fractions: sixths and fourths. First we have the sixths: pi 6, 2 pi 6, or pi thirds, 3 pi 6, or pi halves, and we have fourths: pi fourths, 2 pi fourths, or pi halves, 3 pi fourths, and so on. Then we can use our unit conversions to find our degree angles from our radiant angles. And that's the unit circle. If you want to learn more about trig functions, how they're calculated and where they come from, and trig identities, subscribe, because I will release a video where we dive into the nitty-gritty of trig functions. As always, thank you for watching, and I'll see you next time.